Hello, welcome everybody. Here's your mini video on 10-5, tangents. Tangents are kind of a very important part of math as you keep moving forward. Tangent lines are the basis of calculus in more advanced math. But today we're just going to touch on simple little tangents of a circle. A tangent line in a circle is a line that intersects the circle at one point and is perpendicular to the radius at that point. So if I have a circle here, and I have a line that goes like this, like this, and I draw in my radius, as long as these two lines end up to be perpendicular, we can then call that line a special name. It's called a tangent. The only way to make it tangent is to just nick the circle on one point. If you nicked it at two different points, it changes. It's not called a tangent line, it's called a secant line. So if you have two tangent lines from the same point to a circle, then they are congruent. So if I extend these as my radius or my radii, and I put the right angles in there because that's the definition of those being tangent lines, then I can tell you that these two segments outside the circle here are congruent, which would be equal. Three quick little examples here for you. Here's example number one. Is LM a tangent line? Well, if this LM was a tangent line, then this would have to be a right angle. The only way to make a right angle then is if this entire triangle here, triangle LMK, is a right triangle. Well, how do you check to see if you have a right triangle? Well, of course, you'd use the Pythagorean Theorem. A squared, in this case A is 20, plus B squared, which is 21, that must equal C squared, which in this case is the hypotenuse, which is 29. Grabbing my calculator to verify all this, if I do 20 squared plus 21 squared, I'm going to get the number 841. And now I'm going to check to make sure that 29 squared is also 841. And it is. So since the Pythagorean theorem holds, this triangle is a right triangle, therefore LM is a tangent line. Well, let's try this one when we have the same situation as above, although this time we're trying to find x, some unknown. In this case, it would be the radii of the circle, or the radius of the circle. Well, to do this, I would once again say, well, this is a tangent line, and it is, because of the right angle there, then this would have to hold on the Pythagorean theorem. Pythagorean theorem is vital for most right triangle problems. So I'm going to do A, which in this case would be the smaller leg, squared, plus B, which would be the longer leg. That must be equal to C. A squared plus B squared must be equal to C squared. Now C is tricky. C is this whole long hypotenuse, and this part here is 8, and the radius is x. So to get that entire side, I need to do x plus 8. That's the entire side squared. Now this is somewhat tricky. You'll have to remember your foiling techniques, if hopefully that rings a bell, from last year. I'll write this as x plus 8 times x plus 8, because that's what a square means. And then I'll have to square it. So the first would be x times x, which would be x squared. The outers is 8 times x, which would be 8x. The inners is 8 times x, which would be 8x. Oh, I'm running out of room. And I'm sorry, I'm going to have to put this on the bottom here. And then plus 64. That would be equal to this guy, which is x squared, plus this guy, which is 144. Well, the beautiful thing is I have an x squared on both left and right. So if I subtract like this x squared from this side, that'll cancel, but it'll also cancel this. So I'm going to move to black, and I'm going to kind of finish my problem up here because I'm running out of room. So I've got 144 on the left, and I've got 8x squared plus 8x squared. So I can add those. That's 16. I'm sorry, not x squared, just x. 8x and 8x is 16x. Just add what's in front. And then don't forget this 64 plus 64. Now it's just a simple linear equation. So I would probably minus the 64 from this side and this side. So all I have to do on my calculator is do 144 minus 64. That gives me 80. So I get 80 equals 16x. And then I divide both sides by 16 to solve for x. I get x equals 5. And that's what my x would be. And this last problem is find x again, but unlike the last problem where they formed a triangle here, this is kind of like, looks like an ice cream cone thing. That's what I would think about. Sometimes you'll see this in machinery where you have a pulley or a wheel like this, and then you have a belt going to a smaller wheel, and you might have this belt running around. This is how engines are powered, so this is a good kind of application for the real world. The segment appears to be tangent. You can assume it's tangent, so I'm going to assume that this baby's tangent. So if I'm going to find x by that property from your blue sheet, these two segments are equal. Congruent, it says. So 2x equals 6x minus 4, and you solve. Minus 6x to both sides, and you get negative 4x equals negative 4. You divide by negative 4, x equals 1. That's your lesson for today, mini lesson for 10.5 on tangents. Thanks for listening.